Hey everyone, my name's Jeff Wagner. I am the infrastructure lead at Open Forcefield, and here's our February 2025 infrastructure update. The format of these updates are slightly different from the science updates. In these, basically every month I lay out a couple goals that we're going to try to accomplish in the coming month, and then in the next month's iteration, I tell you if we have accomplished those. So last month we had planned a couple things for significant progress. We had committed to building a prototype of the post-translational modification workflow using our new PDB loader. We had every member of the team contributing to this, and that is complete. And I'll be showing you that on a later slide and walking you through that as well. We wanted to re-enable the fitting of virtual sites in Force Balance. Currently, Force Balance has kind of a maintenance backlog. We didn't get to this last month, so this is red for not progressed. And we wanted to make the interchange 041 release that removed the experimental tag from several methods, as well as making some other updates that users had been asking for, and this is out in the wild. On the note of interchange, we do want to say we're doing a survey of interchange users or potential users, and we really want to get feedback on what features people want, what existing features need improvement, and where they see gaps in our interoperability that would otherwise fill their use cases. So I'll go ahead and put this in the chat as well. But please fill out this survey. We really want to get as much information as possible, and if you're interested, you could also be looped into ongoing updates on Interchange, where you could get updates and continue to give feedback to the developer team. For the next month, we want to continue making progress on force balance. We don't want to let that stall because this is core to our fitting stack currently, and we don't want to let this fall out of date. Josh Mitchell will be beginning an effort to document B-Smarts. This is a really promising tool that's coming out of the Mobley lab at UC Irvine, led by Trevor Goki, who is defending his PhD. And this is a way to automatically generate smarts from a data set. So our current force fields start with a list of smarts, and then we fit the numerical parameters to them, and sometimes we have human intervention when we think that a new smarts, like a unique new parameter is needed. This instead has the computer making the decisions about which smarts there will be. So this is a really cool technology. We want to make sure that we we grab as much of this information as we can before Trevor leaves us and moves on to his next position. So Josh Mitchell will be working with him to flesh out the documentation there. Matt's leading several ecosystem updates. One that's currently in progress is the update to the Pint unit handling package up to version 0.24. He's already updated several packages in the ecosystem, and basically I'm just holding him back, reviewing some PRs that he's open to get the others. We've been getting some feedback that parameter assignment can take a long time for big polymers, and in particular, we found a really bad case where having a couple medium or large polymers in the same topology that aren't identical to each other, but maybe they're similar to each other, this can lead to really bad runtime. That's causing trouble for some materials work and, in fact, formulations applications. So we want to improve that in the coming month. And as I said, we'll be putting this PTM workflow prototype in your hands. And we want to get as much information as possible about that. There's parts of the implementation that we're pretty much committed to now, but there's other parts that are still kind of wet cement. And the more feedback we can get at this stage on if the prototype is just already serving people's needs or if they're finding parts of it pokey, the more fundamentally we can solve those problems before we've made these design decisions in a full release. So let me talk about this modified protein workflow. Um, One of the biggest limitations that we've identified, many of you know that we've done these PTM vignettes or little workshops on how to simulate modified proteins, and one of the most painful parts is loading in an unexpected modification from the 20 canonical amino acids from a PDB file. These things don't often have standard residue names, and figuring out how to get the cheminformatics representations of these molecules with bond orders and formal charges can be very challenging. The people who have been coming to the workshops who gave us feedback on what their inputs look like made us realize that we need to make our own PDB loader. And this will be able to load all the canonical stuff from the chemical components dictionary that's published by the Protein Data Bank. But also, it should be able to allow users to define new residues. So if they have a conjugated drug attached to an amino acid on their protein, they can define that as a new residue easily and pull that in. So that's what we're hoping to accomplish with OpenFF Pablo. This will also lay down the foundation for, in the future, loading nucleic acids. They follow similar rules to how proteins are defined. And so we can just pull these templates down and use the PDB's own specification for loading these things correctly. So in the prototype of the modified protein workflow I'm going to show you, this uses Pablo and it adds a new residue definition. So it's got a cysteine modified by being conjugated to a small molecule. And we define a new residue using using a canonical cysteine from our DKIT, and then we use a SMARTS reaction or a canonical cysteine from the chemical components dictionary. And then we use our DKIT to perform a SMARTS reaction on that. And we conjugate the small molecule. The tricky part here is that in Pablo, we do the matching using residue and atom names. And that means that however the covalent docking was done beforehand, whatever atom names it left things with, the definition of those atom names has to be the same in this residue that we're making for the loading. So we show you one example of how to do it. You're all clever people. You could do maximal common subgraph searches, your substructure searches, or other things to figure out how to assign these atom names. And this is a place where we can add new API points to help you. But we need to get feedback early about how this is difficult for you so we can engineer a fix. And alternatively, many of you are already doing work with PTMs, and instead of using residue and atom name matching, you're matching to element and connectivity graphs. This functionality is still there. It will continue to still be there. It's going to get rolled into Pablo, but the API is going to remain the same. You shouldn't notice any differences. So if you're okay before, this workflow should make it easier than ever. Once the protein is loaded, things are pretty easy. We solvate the modified protein in a water box. People who had been using the old workflow might find this next step helpful. We are putting in a method. So right now we have a prototype of this that you can try that takes away a lot of the complications of of blending these two force fields and dealing with charge methods. It really, we can simplify this down and handle a lot of the stuff behind the scenes where we're assigning the canonical residues, FF14SB parameters, that's valence parameters, non-bonded charge, everything, just vanilla FF14SB. But then for modified residues, we assign them SAGE parameters, and we give those Nagel charges. Those can be calculated really quickly. Again, for people who had previously used our old PTM workflows and you had to define a library charge and it was horrible, this is way, way easier now, and we've hidden this all behind a single line of code that will be maintaining the function behind that to make your lives easier. And finally, this notebook simulates that complex. So I'm about to show you the notebook. We'll walk through it briefly, but it's got you're supposed to take this home and try it on your systems. And I think it for a lot of you is just going to work out of the box and blow your mind. But this is a big deal. This means that this is the beginning of our official support for PTM handling. So it's no longer a little recipe that we showed you in a workshop, but this is actually the beginning of a product that we're going to continue maintaining. It won't always be this Frankenstein of FF14SB and SAGE. We're still working on Rosemary. One of the reasons we're rolling out this in sort of the Frankenstein phase is because Rosemary is taking a while. But once Rosemary's out, we'll be able to easily switch this over. There should be no change in the workflow for you users, and we'll be able to substitute in this fully consistent parameter set using Rosemary for all parts of the modified protein. And this is the big thing, and I'm going to keep reiterating on this. We still have some flexibility on this workflow design, but we really need you to try this and tell us what's difficult about it. And then we can put in new API points to help you do the PDB loading easier, to speed up different parts of this if you're finding some parts are slow for your system because we didn't think about some aspect of how you're going to be using it. We would really like you to go and try out this workflow and tell us what doesn't work.